My name is V. Dinesh, and the topic is mean of normal distribution, and the subject is probability and statistics. A normal distribution, sometimes called a bell curve, is a distribution that occurs naturally in many situations. For example, the bell curve is seen in tests like the SAT and GRE, properties of a normal distribution. The mean, mode, and median are all equal. The curve is symmetric at the center, that is, around the mean mu. Exactly half of the values are to the left of the center, and exactly half of the values are to the right. The total area under the curve is 1. Parameters Parameters of the normal distribution. As with any probability distribution, the parameters for the normal distribution define its shape and probabilities entirely. The normal distribution has two parameters, the mean and standard deviation. The normal distribution does not have just one form. Instead, the shape changes based on the parameter values as shown in the graphs below. Mean. The mean is the central tendency of the distribution. It defines the location of the peak for the normal distributions. Most values cluster around the mean. On a graph, changing the mean shifts the entire curve left or right on the axis, and the graph of norm the graph of normal distribution, different means and same standard deviation is shown on y-axis. It is taken as probability density function. On x-axis, it is taken as values. Standard deviation. The standard deviation is a measure of the variability. It defines the width of the normal distribution. The standard deviation determines how far away from the mean values tend to fall. It represents the typical distance between the observations and the average. On a graph, changing the standard deviation either tightens or spreads out the width of the distribution on the x-axis. Larger standard deviations produce deviations that are more spread out, and the graph is shown as and the graph is shown. On y-axis, it is taken as probability density function, and on x-axis taken as values. And the graph represents same normal distribution, same means different standard deviations. When you have the narrow distributions, the probabilities are higher that values won't fall far from the mean. As you increase the speed of the distribution, the likelihood that observations will be further away from the mean also increases. Probability density function. The normal distribution is formally defined by the probability density function. Psi of x is equal to 1 by root over 2 pi sigma square into e power negative e power of negative x minus mu whole square by 2 sigma square, where mu and sigma are fixed constants. E power x is equal to exponential function. Standard normal distribution. How to find probability steps. Step 1. Draw a bell curve and shade in the area that is asked for in the question. The example below shows z greater than minus zero point 0.8. That means you are looking for the probability that z is greater than minus zero point 0.8. So you need to draw a vertical line at minus zero point 0.8. Standard deviation from the mean and shade everything that's greater than that number. Shaded area is z greater than minus zero point 0.8, and the graph is shown below. Step 2 is visit the normal probability area index and find a picture that looks like your graph. Follow the instructions on the page. To find the z value for the graph, the z value is the probability. The other reasons why normal distribution is important. In addition to all of the above, there are several other reasons why the normal distribution is crucial in statistics. Some statistical hypothesis tests assume that the data follow a normal distribution. However, as I explained in my post about parametric and non-parametric tests. There's more to it than only whether the data are normally distributed. Linear and non-linear regression both assume that the residuals follow a normal distribution. Learn more in my post about assessing residual plots. The central limit theorem states that as the sample size increases, the sample distribution of the mean follows a normal distribution, even when the underlying distribution of the original variable is non normal. And that's it. Thank you, everyone.